All right, here we go once again. We are now ready for lesson 2, points on the number line. For activity number 1, we're given a number line here with a point B labeled, and it asks us which of the following numbers could be point B. So which one of these values would match point B? If you haven't already done this, go ahead and circle those that you think are right. Let's go through each one of these. Could it possibly be 2.5? Well, 2.5 would live between 2 and 3. That is true, so I think that is a possibility. Let's circle that. That's a yes. How about 2/5? 2/5. Well, 2/5 is less than 1 whole because 5/5 would be 1 whole, right? So that would be less than a whole. In fact, it would live somewhere over in here. So no, I don't think that one will work at all. Okay. How about 5/2 though? Well, 5/2 is an improper fraction. And if we were to find the mixed number for that, 2 goes into 5 twice with 1 left over, so it's 2 and 1/2. Could this possibly be 2 and 1/2? Yeah, that's actually equivalent to that, isn't it? So that is a yes. Okay? How about 25/10? Well, 25/10 once again is an improper fraction. Let's see what that would equal as a mixed number. 10 goes into 25 twice with 5 leftovers, so I have 2 and 5/10. But even 5/10 can be simplified to 2, look at that, 2 and 1/2. It's actually the exact same thing as what we just did, so that must also be a yes. Okay? Last one is 2.49. Ooh, 2.49 is super-duper close to 2.5. Do you think that could be a possible answer? I do, because do we know exactly where that is? Could it be 1/100th away from halfway? Yeah, I think it could be. I think that's a possibility. How did you do? Did you get all 4 of the right answers? I hope so. Let's go on to the next activity. This next activity has a bunch of thermometers. I like this one. Let's read the instructions. Here are 5 thermometers. The first 4 thermometers show temperatures in Celsius. Write the temperatures in the blanks. Okay, so it looks like we're just looking at these and figuring out what temperature they're at. We know how they work, thermometers. We just look at the dark part, and wherever it stops, that's the temperature, right? So if I look at this, look at that. It stops right at the 1. Now, is that a positive 1 or a negative 1? Oh, there's 0, so it must be a positive 1. 1 degree Celsius. Part B. It stops clear down here, and if we look, that is exactly on -2. 2 degrees below 0, so that must be a -2 degrees Celsius. Part C. Clear up to here. Oh, look at that. Here's the 3-degree line. Here's the 4-degree line. And where are we? Looks like we're halfway in the middle, right? So that must be 3.5 degrees Celsius. Okay? D. Looks like it's clear over here. Oh, this one's a tricky one. Here is 0, and here's -1. And this looks like halfway between -1 and 0. So this one is tricky because a lot of kids are tempted to do -1.5. But it's not -1.5 because -1.5 would be 1 whole and a half. -1.5 lives between -1 and -2, and that's not what we have here. We're halfway between 0 and 1. What's halfway between 0 and 1? 1/2, or 0.5. And since we're on the negative side of 0, it's a -0.5 degrees Celsius. Now, on this last temperature, or this last thermometer, we have a bunch of blanks that we have to figure out. Okay, the first thing, what is the temperature that's shown here? Well, it's obviously at -20 degrees. So let's write that on the line, -20 degrees Celsius. But we have to figure out the rest of these blanks. So what are they counting by here? 20 and then something and then something and then 5. I'm wondering if they're counting by 5s. 20. Well, let's go from 0. Where does 0 live? Oh, we don't even have 0 marked on here. Let's see. I think this one is 0. Let's try it. If I go 0, 5, 10, 15, 20, yep, I think I was right. Negative 10 would be there. Negative 15 would be there. Now if I go up by 5s, we would have 5, 10, 15, 20, 25. So I think we did it right by adding 5 degrees to each one of those. Okay? So that's what we did. The last thermometer is missing some numbers. Write them in the boxes. So we're done. Activity number 2. Easy peasy. Good work, guys. Oh, just kidding. We're not done with activity 2. We still have numbers 2 and 3. Let's do these real quick. Number 2. Elena says that the thermometer shown here reads negative 2.5 degrees Celsius. Negative 2.5 degrees Celsius. Because the line of the liquid is above negative 2 degrees Celsius. Jada says that it is at negative 1.5 degrees Celsius. Do you agree with either one of them? Explain your reasoning. Well, this is kind of like what we just did back here on this problem. We have to look at what we're in between and be super careful about where our halves are going to fall, right? So looking at this one, I am in between negative 1 and negative 2. So it's a bigger number than negative 1, but not as big as negative 2. So could it possibly be negative 2.5? Nope, because that doesn't live between 1 and 2. The only one that does is negative 1.5, so Jada must be right. I agree with Jada. And then to explain why, because negative 1.5 is between negative 1 and negative 2 degrees Celsius. Okay? One morning, the temperature in Phoenix, Arizona was 8 degrees Celsius, and the temperature in Portland, Maine was 12 degrees Celsius cooler. What was the temperature in Portland? Okay, this is a great one for a drawing. So I'm going to draw a quick vertical number line. Arizona, okay, we need a 0 on here, so let's put 0. Arizona was at 8 degrees Celsius, so we're going to go up to 1, 2, 3, 4, 5, 6, 7, 8. There's Arizona at 8 degrees Celsius. Arizona. Okay? Temperature in Portland, Maine was 12 degrees cooler. Well, cooler means going down, so it's cooler than this, so 12 degrees lower than this. So once again, we have to count. 1, 2, 3, 4, 5, 6, 7, 8. Of course, that would get us back to 0. 9, 10, 11, 12. We live down here. There's Portland, Maine, but where is it? Or what is the temperature? Well, let's figure this out. Here's our 0 again, and we are 1, 2, 3, 4 degrees below 0. 4 degrees below 0. What's a better way of writing that? We already know, negative 4 degrees Celsius. Okay, so there's our answer for that. We just finished activity number 2. Moving on to activity number 3 now. This is going to be a fast lesson, I can already tell. Your teacher will give you a sheet of tracing paper. Yes, she will. Well, no, she won't. I have one. I hope you have some kind of paper to use at home. Now, it does not have to be tracing paper. The cool thing about tracing paper is you can see through it, but any piece of paper can be seen through if you hold it up to the light, right? We all have done that. So whatever paper you have, use what you have. It really doesn't matter. We're going to follow these steps and make a number line, a folded number line. These are really kind of fun. So let's go through the instructions. Pause the video, by the way, if you need to go find a scratch piece of paper. Any paper will do, okay? Follow the steps to make your own number line. Number 1, use a straight edge or a ruler. So I found a ruler. It can be whatever ruler you have, or it can be even something like a piece of cardboard or a book or something that has a straight edge. It really doesn't have to be a ruler. Whatever you have is just fine. It says use your straight edge or ruler to draw a horizontal line. Mark the middle point of the line and label it 0. Okay, I can see where we're going with this. We're just making a number line here. So I'm just going to make a nice straight line. I'm going to come down here a little ways and then I'll put it back up. I just want to make sure it's nice and straight. All right, there is my line. I've drawn it on my paper, as you can see. Maybe I'll get this out of the way for now. There is my line. Well, maybe I won't. I don't know. All right, so there's my number line. Step 1 is, we need to label the middle 0. So let's label the middle 0. There it is. Okay. Then it says, to the right of 0, draw tick marks that are 1 centimeter apart. Label the tick marks 1, 2, 3, continuing on to 10. Now, I noticed that my piece of paper is way too small to make 10 tick marks that are all a centimeter. In fact, if I show you here, my paper will only go to about 7 centimeters. Now, I think that will be enough. I don't think we need to go all the way to 10. So I'll leave it up to you. If you want to make it exactly 1 centimeter, then as long as you can get to about 7, you'll be safe. But if not, then just make them smaller. They don't have to be exactly a centimeter, okay? But I went ahead and made my tick marks on the centimeters because I can do that with my ruler, okay? Now I'm gonna label them 1, 2, 3, 4, 5, 6, and 7, okay? So now that step is done. We're pretending we got all the way to 10, okay? As you can see, this is the positive side of our number line, okay? Next step, okay, so we've done that one, we've done that one. Fold your paper so that the vertical crease goes through 0 and the two sides of the number line match up perfectly. Here's what this is talking about. I'm gonna fold this right on that 0, okay? And I'm gonna make sure my two lines match up. This is why it's important to be able to see through it. So if you don't have tracing paper, put it up to the light and see if you can see through that well enough to know where this fold needs to be. Try to be as precise as you can. Get it folded right there on the 0, and then make sure your lines match up. And I think I've done a pretty good job, so I'm gonna make that crease, okay? So again, I've got a crease right on 0, and I've got my, in fact, mine's a little bit off. Just make my line bigger. And then I've got my number line. Okay, so that line, or that is now done. Done. Use the fold to help you trace the tick marks that you already drew onto the opposite side of the paper. So I'm going to take this and I'm actually going to fold it the other direction. This is what I should have done the first time. Fold it the outside way so that I can draw on my line. Now when I flip it this way, do you see how I can see through? Now again, if yours isn't as see-through as mine, that's okay. You'll just have to use, put it up to the light and put it down, put it up to the light, etc. But I can see that my first tick mark is right here. There's another one, there's another one, there's another one, there's another one. There's 6, and mine on this side won't go to 7, darn it. But that's okay. I'm gonna label these now. What do you think I should label these? It even tells us. Unfold and label the tick marks -1, -2, -3. You see how this works? So now I have a perfect number line, and now -1, -2, -3, -4, -5, and -6 are perfectly labeled on my number line. And it is important that we have all these tick marks equidistant from each other. We talked about that a long time ago, but it is important that all of our tick marks are the same distance. That's why tracing paper is so great to help us make sure that everything lines up perfectly. So now we are done with that step and we're ready to flip the page to number 2. Here it comes. Number 2. Use your number line to answer these questions. Which number is the same distance away from 0 as the number 4? Okay, so if we're comparing number 4, and I want the number on the other side that's exactly the same distance away, here's a fast way to do that. Fold your paper back up. Which number is exactly the same distance away? Well, look at that. It matches up so perfectly. It's right on top of each other, but that says -4 under there. And does that make sense? Is -4 the same distance away as +4? It certainly is. So our answer is -4. Which number is the same distance away from 0 as the number -7? Well, I don't have a -7 over here, but if I did, what would it line up with? You can already see it on my paper here. It would be -7, wouldn't it? positive 7. Positive 7 is on the other side of negative 7. Two numbers that are the same distance from 0 on the number line are called opposites. There's a bolded word. That must be a vocabulary word, and it is. Opposites are numbers that are on the opposite side of the number line. Find another pair of opposites on the number line. Well, there are lots of opposites on this number line. How about negative 1 and positive 1? My lead decided to freak out. Negative 1 and positive 1. What's another set? Well, any of these would work. How about negative 5 and positive 5? As long as they're the same distance, 5 units away, 1 unit away, it doesn't matter which one you pick. Those are called opposites, okay? Determine how far away the number 5 is from 0. Well, that's 5 units away from 0. Then choose a positive number and a negative number that is each further away from 0 than the number 5. Well, if we're looking at something that is 5 units away, so now we're looking at 5, I want something farther away, right? So 6 is farther away from 0, 7 is farther away from 0, and if this kept going, 8 and 9 and 10 and 11 and 37 would be higher or farther away from 0, right? So all we need to do is choose a positive number and a negative number that's both farther away. So here we go. How about 7 and negative 7? Wouldn't they both be farther away? Because 7 would be 7 units away. Negative 7 would also be 7 units away. That's more than 5. So there's an answer. Okay? Determine how far away the number negative 2 is from 0. Well, we know negative 2 is 2 units away from 0. So that's that. Then choose a positive number and a negative number that is each farther away from 0 than the number negative 2. Well, here we go. Negative 3 is farther away. Negative 4 is farther away. Any of those are farther away than negative 2. So I'm going to say negative 6. And if negative 6 is further away, then so is positive 6. Because positive 6 is 6 units away. That's way more than 2, right? So that must be a good answer. Okay? Now, it says to pause so I can look at your work, but of course I can't look at your work, so we're going to keep moving on. I hope you're following along. Here is a number line with some points labeled with letters. Determine the location of points P, X, and Y. Now, here is a great opportunity to do some folding. I really like this one. I'm going to make my 0 line really dark so that when I fold it, I can tell right where it is. And this paper, just like yours, is not going to be see-through. So I'm going to show you how this can still work, even with paper that is not tracing paper. I'm going to use the light here. I'm holding it up a little bit so that I can use the light to help me. There we go. Now, when I look through this paper, and I know it's hard to see on the video, but I'm going to look through the paper and I'm going to mark where I see the other points on my line. I'm going to look through and I'm going to notice, oh, look at that. Y is in the same location as 8 on my other side. And I did that by looking up through the light. 8 and Y are in the same position. So on this side, I'm going to write negative 8. And then I'm going to do the same thing to point X. I'm going to look through the light. In fact, you know what I'm going to do? I'm going to mark little tick marks. I'm going to put a little tick mark on 1. There's 1 on 2, 1 on 3. One on 4, 5. You know what? I must have counted wrong. This is negative 7. Let me go back to my double check here. Yep, I was right. It's negative 7. So even here's the hint. Trace the number line and the points on a sheet of tracing paper. Fold it so you can do that. So maybe I should have traced it and then done it perfectly on tracing paper. But I know you don't have that, so I did it the way you would have to do it. So that is at -7. X must be at -1, 2, 3, 4. And P is at -2. And if we look here, that looks to be exactly right. 4 and X look about the same distance away. 7 and Y. Yep, those look right. Guess what? We just finished our lesson. Good job, guys. Now, once again, are you ready for more? That is optional. But you're certainly welcome to do it, honor students. If you want to try that, that would be super great. Don't forget to take a look at the lesson summary page. Make sure you study that and understand what we covered today. And then, of course, here's our new vocabulary for today. If you don't understand what those words are, look them up in the glossary. Thanks for joining me today. I hope you're having a wonderful week. We will do homework next. Do it on your own first. Don't forget. Don't cheat. Don't lie. Do your very, very best because...
Do your best because you deserve your best.
All right, here we go once again, ready for homework for lesson number 2. Once again, like always, I hope you've already done this homework and then all we need to do now is check it. So let's go quickly through this one. Here we go. Lesson number 2, number 1. For each number, name its opposite. If you remember from yesterday or from our lesson today, an opposite is the same distance away from 0, just on the opposite side of 0. So if I'm at -5, the opposite of that would be +5. Okay? B, 28. Well, the opposite of that would be -28. -10.4. Ooh, can we have negative decimals? You bet we can. -10.4's opposite would be +10.4. Don't forget that decimal. It is important. Okay, part D, 0.875. Well, that is positive, so the opposite would be -0.875. Okay, 0. What is the opposite of 0? Well, what's the same distance away from 0 as 0? This is a tricky one that always gets kids, but the answer is actually 0. 0 is the only number that is its own opposite. Okay, so the opposite of 0 is 0. Weird, I know, but it's true. Okay? -8. Oh no, this is -8,003. Wow. Well, that's going to be +8,003. Awesome. Number 2. Plot the numbers -1.5, 3/2, -3/2, and -4/3 on the number line. Label each point with its numeric value. So we need to make sure we label these as we go. Not just dots, but labels as well. So let's start with -1.5. Well, here's 0. Negative means we have to go to the left. There's -1. The 0.5 is 1/2, so that's going to be halfway between -1 and -2. There's not a tick mark there, but we can add one. Just be careful. There's a tick mark about halfway. And I'm going to put a big dot right there and label it. I'm going to put the labels up above. -1.5 lives right there. Okay? Next is +3/2. Now that's an improper fraction, and for our purposes, it'd be a lot easier if we knew what that was as a mixed number. So let's do that. +3/2. 2 goes into 3 once with 1 left over, so that's 1 and 1/2. So +1 and 1/2 is going to live about right there. I'm going to put a nice big dot and label that. Now I'm going to go back and put 3/2 because that's what originally it had, but we know that's also equal to 1.5. That just helped us get there. Okay, so we've done that, we've done that. -3/2. Oh, look at that. That's the opposite of the one we just did. So if I go to +1.5 on this side, I have to go to -1.5 on this side. Oh, look at that. It's the exact same point as this. And we know that 3/2 is equal to 1.5. So that makes sense. So I'm going to label -3/2 down there at the exact same point. Okay, so now we've done that one. -4/3. Here's another improper fraction. So let's turn that into a mixed number. -4/3. 3 goes into 4 once with 1 left over, so 1 1/3, but it is negative. So -1, and that was 1/2, but now I need thirds. So 1, 2, 3 thirds, approximately. So there's my -1/3 is approximately right there, and I'm going to label that one with -4 thirds. -4 thirds. There we go. -4 thirds lives right there. We've labeled them all. We're done with number 2. Okay? Number 3, plot the following points on a number line. Okay, so we need to draw a number line this time because they didn't give us one. So let's draw one. I'm going to use the space right down here below. Again, you don't have to have a ruler. You can use any straight surface, a book, a piece of paper, whatever you have. So I'm going to draw a nice straight line. I'm going to make it relatively long because we got plenty of room here. And I'm going to put 0 in the middle. And then I'm just going to put some tick marks. 1, 2, oh, and I should probably, well, it doesn't have to be perfect, but trying to make this as neat as you can and as equally spaced as you can, okay? Now, I haven't labeled all of these, so I should go ahead and do that. And I just made sure that I went further than some of these, so I make sure that I have enough on my number line. Especially when you're going in the negative direction, make sure you're counting from 0. 1, 2, 3, 4, 5, 6. You got to move to the left, which is kind of backwards from what we're used to. Okay? Very, very good. Now we're ready to plot all of these on there. -1.5. -1.5 is going to be halfway in between -1 and -2. So I'm actually going to draw a line up here and do -1.5 is right there. Done. Okay? The opposite of -2. Oh, that's kind of cool. So -2 is here. What's the opposite of -2? Well, that is +2, right? So +2 is on our number line now. So that equals 2. So that is now plotted on our graph. Okay? The next one, the opposite of 0.5. Well, 0.5 is 1/2, or halfway between 0 and 1. So that one lives about right here, but we want the opposite of that. So that must be -0.5, which is right there. And I'm going to, again, do a little line up here to show this is -0.5. -0.5 is that answer, and I've now plotted that. Our last one is -2. So here's my 0, -1, -2, nice big circle on -2. And now that one is done. Okay? So I've made my additions to my number line nice and dark so that we can tell which ones are the new ones. And of course the dots help us too. We have to have nice big dots on all 4 of our points. Okay? Moving right along to number 4. Represent each of these temperatures in degrees Fahrenheit with a positive or negative number. So we're just turning these words into a positive or a negative number. So part I, 5 degrees above 0. There's our key word. So above 0 must mean that's positive. So that is just 5 degrees. And this is Fahrenheit. Part 2, 3 degrees below 0. So that must be a -3 degrees Fahrenheit. Part 3, 6 degrees above 0 is a positive 6 degrees Fahrenheit. And the last one, part 4, 2 3/4 degrees below 0, -2 3/4 degrees Fahrenheit. Or you could write it as -2.75 degrees Fahrenheit. Either way is fine. We usually do temperatures in decimals, but there's nothing wrong with that one either. Okay? Very, very good. Now, part B down here kind of got cut off on mine. I don't know if it did on yours or not, but be careful with that. Don't forget to do this part if it did get cut off like mine. Order the temperatures above from the coldest to the warmest. Oh, so we're looking at these numbers here, and now we've got to put them in order from the coldest to the warmest. Okay, so if we think of these temperatures, which one is the coldest? Well, the negatives are definitely colder than the positives. So let's compare our two negatives. Is -3 colder, or is -2 3/4 colder? Well, I say -3 is colder, so I'm going to do that one first. But then -2 3/4 is a close tie, so it's next. Now our positive numbers are easy to tell. 5 degrees is colder than 6 degrees, so it's next, and then 6. Okay? So there's my numbers in order from coldest to warmest. Awesome. Moving on to number 5. All right. Solve each equation. This, again, is a review from Unit 6. Yay for that. We have to solve these for the variables. I'm going to rewrite this over here. Well, maybe I don't have to. Well, maybe I do. I don't know. It'll get squishy. I'm going to rewrite it. 8x equals 2/3. Right now, x is being multiplied by 8. So the way we undo that is by dividing by 8. So I have to divide by 8. Now, we're dealing with fractions here. 8 is the same thing as 8 over 1. So I could times that by the reciprocal, flip it upside down to get rid of that on this side, right? So now I have x equals, can I simplify before I multiply? I think I can. 2 is a common factor, so 2 goes into 2 once, and 2 goes into 8 4 times. Now that made it simpler. 1 times 1 is 1, 3 times 4 is 12, so x equals 1/12. Okay? Part B. Again, we have a 2 times x here, so I'm going to be dividing by 2. So we've got 1.5. I'm going to switch that to be 3/2 equals 2x. Now I'm dividing by 2, or 2 over 1, right? And to do that, I flip it and I multiply. There we go. Those are gone now. And there's nothing to simplify, so my answer, 3 times 1 is 3. 2 times 2 is 4. So there's my answer for part B. Now, part C, same idea here. I'm actually going to do it right under here to save me some room. Here's some divide by 5, or that's 5 over 1. So I'm going to times that by 1 over 5. That goes away, leaving me with x equals 2 times 1 is 2. 7 times 5 is 35. So x equals 2 over 35. Okay? Moving right along. Same idea here, except this time we're dividing by 1/4. Dividing by 1/4 is the same thing as timesing by 4 over 1, right? Timesing by 4 over 1 will get rid of both of those. So x equals, I'm going to turn that into a fraction. 5 times 4 is 20. 1 times 1, oh, I didn't even really need to, because x equals 20 over 1, or just 20. Okay? Last one of this section. We're timesing by 2/3, which means I need to divide by 2/3, or in other words, times by the flip of that, the reciprocal of that on both sides. I'm going to times by 3/2 on both sides. Both of those cancel, giving me x. 3 times 1 is 3. 2 times 5 is 10. So x equals 3/10. Those were a little tricky. Did we get all of those? I hope so. If not, if you're not sure how to do these, there's lots of resources I've added online, or you can certainly email me and I can go through those a little bit more slowly or differently with you. Okay? Number 6, write a solution to each equation as a fraction or as a decimal. So if I need to solve for x here, I need to once again divide by 2, divide by 2. Those go away and I can leave this as a fraction. So that's just 3/2. Done. Okay. Could I have changed that to a decimal? Yes, but you don't have to. Same thing happens here. If I have 5 times y, I just have to divide by 5 on both sides. 5's go away here, leaving me with y equals 3/5. Done. Here's where the decimals come into play. I have to undo this multiply by dividing by 0.3 on both sides. Now, we have to remember our decimal tricks, right? 9 divided by 3 is 3. But how many decimal places do I need? Well, if I'm dividing by a decimal, this has to move once. So it has to move once here too, right? So that means that I'm going to have 2 decimal places. So there is my answer. 0.03 is what equals Z. Does that make sense? Last one, number 7. There are 15.24 centimeters in 6 inches. How many centimeters are in 1 foot? Well, let's compare 6 inches to 1 foot. 1 foot is 12 inches, so that's twice as big, because 6 times 2 is 12. So what I need to do is just take this number, 15.24, and make it twice as big. Multiply it by 2. Now that's a funny way to do this. I'm going to go off to the side here to make sure I'm still in my camera and do 15.24 times 2. 4 times 2 is 8. 2 times 2 is 4. 2 times 5 is 10. 2 times 1 is 2, plus 1 is 3. Now, before I'm done, I have to pay attention to that decimal. I have 2 decimal places in my products, so I have to have 2 decimal places in my quotient, or my product, in my factors. I'm wrong vocabulary. 2 decimal places in my factor, so there must be 2 in my product as well. So the final answer for part A is 30.48 centimeters are in 1 foot. How many centimeters are in 1 yard? Woo, okay, well, 1 yard is how many feet? 1 yard is 3 feet. So if I know that there's 30.48 in 1 foot, I can just take that and times it by 3. So 30.48 times 3 will give me the answer. Once again, I'm going to do my math over on this side. 30.48 times 3. 8 times 3 is 24. 4 times 3 is 12, 13, 14. 3 times 0 is 0, plus 1 is 1. 3 times 3 is 9. There are 2 decimal places in my factor, so there's 2 decimal places in my product. So my answer is 91.44 centimeters. Which really makes sense because 30 times 3 is 90. So we were a little bit more than 30, so we're a little bit more than 90. That completely makes sense. And guess what, ladies and gentlemen? We just finished our second homework. I hope I wasn't too low. Dang it, was I too low? There's the final one if you need it. I hope you had a good time doing this homework. I really like working with negative numbers and positive numbers. I think it's kind of fun. And it's always good to have some review from the units we've done in the past to keep our brains fresh and understanding that material as well. Alrighty, if you have any questions or concerns, you know you can always email me, okay? Please do that. Now you need to take that check your understanding quiz. Don't forget to go back to Canvas, grab that quiz. I think it's only 3 questions. Just do that real quick. Make sure you understand this material before moving on to the next lesson. Thanks, guys. Have a great night.